New pull requests this week. I only saw one new one that showed up in my list, and that is Adam on the core team has a new PR as do not merge for implementing fine-grained locking in BlueFS. And I suspect that that is maybe based on some work that I think Majian Peng did earlier. Oh, Adam, you're here. Excellent. I was just mentioning your BlueFS fine-grained locking PR. Looks like not ready yet, but maybe hopeful.
Basically, it is working. It passed test and it passes various testing, but still, I'm not really satisfied with the possibilities of deadlocks. I have to find out some systemic way of discriminating that this code will not cause any deadlock. Because there is basically one global log has been switched into 4 logs for different parts of BlueStore. And it's not really a progression from least locking to most locking in like kernel layers. It's different domains of action require different logs. So that's why deadlocks are really possible. So I would like to review that more before actually pushing that on anyone. I mean, that's free to look at. Mostly I put there because Gabi wanted to review that. So it's free to look, and please comment if you see anything, but it's not ready for rigorous review.
Out of curiosity, have you tried running it through Teuthology yet?
No, I did not run it through Teuthology yet.
Okay. That maybe would be the first step to see if you hit deadlocks there.
Yeah, I will run it. I will run it through Rados suite. Maybe something pops up.
Yeah, thrashing seems to hit stuff like that pretty well, but not always. Oh, excellent. That was the only new PR that I noticed this week for performance. There were a couple that closed. Let's see, it was a little PR for changing a long double in common to double. I forget even what code that was in, but yeah, that's fine. Makes sense. Maybe a little bit of a win. Let's see. Patrick merged something in the MDS to flush the MD log when requesting the read lock. I do remember looking at this a couple weeks ago. I don't remember very much about it, but it must have been good because Patrick merged it. So that's excellent. And then the B-tree allocator that Kifu wrote. Adam, it looks like you reviewed it and liked it, and Kifu was satisfied, and he merged it. So that's excellent.
Yeah, we are now waiting for a continuation, which will be merging that allocator with hybrid with bitmap allocator, forming hybrid. But for that, I'm owing Kifu a rigorous testing on possible scenarios and threshold when we should switch from B-tree to hybrid mode.
Neat. That's actually sounding quite a bit like what some of the file system, the path that they ended up going down. So it's I think we're on the cutting edge or close to it now. It's good. All right. Let's see. Manager, this time to live cache implementation, that PR has updated testing results, which is nice to see. They included some graphs. Looks like the cache is helping, so that's nice to see. I think that there was more discussion on this AVL allocator PR that has not merged yet. And then scores PG optimization, PG removal optimization, PR. It looks like that's maybe ready for testing, or no, it is in testing. Kifu has it in testing now again, so that's good. Maybe we'll see that merge soon. And that was all I saw for new and updated PRs here. Anything I missed from anybody? All right. Well then, let's see. The only real topic I have for today is that for a while, Josh and Neha were waiting on me to do run some tests looking at the OSD client. What's it called? OSD client message cap parameter. We previously had this set for 100 for many years, and then for kind of an unknown reason, I guess we disabled it completely and got rid of it, so that there was no cap anymore. But I guess that was causing problems in some cases. In Toothology tests, and I don't know, maybe actually in running clusters. Neha, do you, or Josh, do you know, was that actually a customer issue?
No, at least one case that I encountered was one of our RocksDB related tests in pathology started failing. And it was just, the OSDs were just hitting a suicide timeout. And setting this option actually helped in that case, which is what made me think that it does work and it does a good job of, throttling things at the messenger layer. That was one
Yeah,
example, recent, that I remember.
that does not surprise me given how things are architected right now. So, okay. Well, I'm glad at least that we weren't specifically seeing customer issues with it. Although I wonder if maybe
Oh, we
I,
were seeing value.
yeah, I
We,
was gonna say
we
suicide
okay, so
timeout sounds like
we
yeah.
we did see customer issues. The customer issues were there, but the code wasn't there. That was the problem. So we couldn't really ask them to even set this and see if that helped. But we've now finally gotten this code available in the customer releases that people are using. But since then, I don't think we've hit that. So it's not been a long runway, but at least it's there now for us to exercise if we run into such issues.
Sure, sure. Yeah, I was gonna say that suicide timeout does seem like something that people have been seeing like in the last couple of years, and maybe it's been more predominant since we disabled that. But yeah, well, in any event, I've owed you guys this for like a month or two, I think, and I finally over the weekend just went bonkers and ran a bunch of tests on it. Um, and I pasted the results in the chat window, so for anyone that wants to look. I personally don't find it super interesting. It's kind of what you'd expect to see. At really small message caps, it's slow. Not actually. Maybe one surprising thing in this is actually it's faster in a number of these tests, even with a really small message cap than I expected. Which mostly sequential, which makes sense, right? Because you might have like merging of IOs happening or whatever. So that is maybe less surprising, but in general, I mean, like the what we had set to before 100 was not super unreasonable. We do a little bit better if it's set a little higher. So like in the core stand-up, we were talking about like 256 maybe, just being the new default. But really, some reasonable cap is not completely like yeah, it's kind of just straightforward. There's no reason not to, in my mind, at least based on these results. Yeah, both RBD and RGW kind of follow similar patterns. Nothing real super exciting. What I will say though, actually, in this is that we're seeing this really weird behavior with 128K random reads, where like it's oscillating between like it's almost like a binomial distribution, where half the time it's like fast and half the time it's slow. And there doesn't seem to be a whole lot of rhyme or reason to it. So that's something that needs to be figured out. And I don't know if that's related to the throttling or not. but we always have had really kind of strange issues with that IO size with around there, like these middle IO sizes, and it's not never been totally clear to me why. Um, but that is what it is. More work needs to be done there. The other thing that came through in these results is that uh, for large sequential and random writes, like 4 MB ones, we're like getting between 13 to 15 gigabytes per second. And on Pacific, I was seeing closer to 20 to 25. So we may have a sequential write regression in master that I need to go look at and track down, um, or at least figure out why it's happening. So um, there's that too. But that was really what came out of all of this in my mind is a couple things to look at, maybe fix, and some message cap value of like between 100 and 500 is probably fine. One thing that we talked about a little bit in the core stand up earlier this week or last week. Um, I don't understand why we don't tell clients to back off and have some kind of flow control. It seems like it would be really like a good idea. What do you guys think?
I agree. I think that we have something very coarse-grained in existing OSD backoff code, which only kicks in when there are cases where we know that we can't service operations for a long time, like the object needs to be recovered or the PG is peering or otherwise inactive. And then we ask the clients to back off for a while until we tell them it's ready to go again. But yeah, I agree that better flow control would be great, helpful. I think we're like the message cap is kind of a very simple kind of throttling approach, but something it doesn't help in all cases, and it doesn't really prioritize things or provide any level of like quality of service that you might get with a better or more complex flow control algorithm.
Josh, the other thing too, right, is that the client right now with the message cap is just going to sit and block, right?
Yeah, I don't think that's necessarily a problem. I mean, that's what lots of flow control algorithms end up doing, right? They end up blocking at the client side rather than the server side.
Sure, but like they could sleep, right, or do something like they could just you tell it I don't want you to contact me for like 2 seconds or something. Then it could
Sure.
it wouldn't be hanging around. It'd just be like okay, fine, whatever. I'll go do other work or I'll just sleep here.
But yeah, it's not blocking the whole client though. It's just like that particular connection to that OSD. So I don't think that there's much of a difference in that sense between the message
Okay,
cap and a different kind of flow control algorithm.
okay. I One of the things I've noticed is that it seems like under really like in situations where the OSD is not responding, I see like clients spinning at 100% CPU sometimes, and I was curious if that was why.
Hmm. I don't think so. I think if we are seeing that, that's maybe some kind of bug, or just
Okay,
yeah.
okay, interesting.
Yeah, I'd
Maybe
be
I'll have
really
to.
interested to learn more about different kinds of flow control schemes. I'm not actually familiar with many of them myself.
Yeah, I actually just this morning was looking at like TCP and Cameo. The original implementation was just like, okay, you send like a frame back and say, okay, I want you to wait for some period of time, right? But then at some point they did a much more kind of interesting like QoS type scheme where they could have different kinds of uh, and I don't actually know that much about it other than that it looked like it was more advanced and let you kind of have different classifications of flow control.
Yeah, it might be more interesting to think of this as well in different contexts for the future interfaces we have worth thinking about for Ceph, like with any protocol changes we want to make for Crimson or with NVMe EOF, having more direct connections.
Yeah,
What kinds of things could we do there?
definitely. Hey, Sage.
Hello.
I think you're. Oh, there you go.
Yeah.
Yeah, I guess in general, I'm not even sure about all the other different things that more complex flow control could help with. Since I'm not very familiar with the algorithms.
Something in lines of this. Remember, Josh, there was some discussion about doing some flow control at the RGW layer, just for the RGW workloads. There was a PR from somebody who's trying to implement something of that sort.
Yeah, I can't remember exactly what that was at this point, but I remember that being that existing in some form.
Yeah, I think at some point the RGW folks were very interested in that, which is why we also looked at it. But after that, I don't know much happened to that or not.
Adam Emerson, do you remember about anything in flow control in RGW?
They're currently discussing it. I think DM clock, pardon me, DM clock is used in the Beast front end. They were just discussing it in an email today. But apart from that, it's still under discussion.
Okay, thanks. Yeah, I think there was something in addition to DM clock that had come up before too, but I can't remember what it was.
What would be the advantage of doing it specific to like RGW like that versus something more kind of Rados level?
Could have more awareness of like the metadata. Like if you're blocked on a particular bucket, you could stop all operations that bucket, not just the Rados objects individually. Maybe.
Sure, maybe.
Yeah, the policy is probably going to be per bucket on the RGW side, right?
Yeah, you might want to integrate with like RGW's level of QoS as well, since it's going to have a different division of tenants than Rados will.
Sure.
Are we talking about the OSD client message cap? That
Yeah, I was wondering why we don't just do flow control, like actually let the client know to just sleep for a while.
Yeah, I guess I don't really know how those algorithms work. So
That's exactly what I was just saying.
like how long? I mean, TCP does flow control when you stop reading off the socket, which is effectively what we're doing. So we're just sort of like piggybacking on TCP's flow control. I think that, but my recollection of the ARM talk was just that they increased that and it increased performance in their tests. And it wasn't clear to me that there was really a downside of just increasing that in general. But I think there was also a separate memory cap, right? So we already have like a...
Yeah, there's like 100 megabyte memory cap or something like that. But
yeah.
Today the default is the message cap is turned off, so that's what Mark ran some tests, and now we have a reasonable value to add as a default that won't impact performance.
Yeah, for many years we had it set to 100, the message cap, and now we just don't have one. We just got rid of it for some reason. No one really seems to know why. And then we should just turn it back on.
Yeah, just keep it high enough that it won't affect most people. Yeah, I think my recollection is that the message cap and the memory cap are both global, which means that there's some like, if you have one client that comes in first, it can fill up the queue effectively, or fill up that cap, and then other clients come in, they won't be able to. It'll have a harder time sending messages. So there's
Yeah.
like a little bit less there in that case, even though they're like the dequeuing underneath is there. So, but that should even itself out over time, like a first mover advantage or something.
I might take a stab at just looking at the throttle code. I started looking at it a little bit yesterday or the day before or something, and just seeing if there's any clever way to make it a little more clever.
Yeah.
We'll
Did
see.
you say somebody was already using it? The ARM talk, or are they using? What value are they using? Do you know?
It was in that presentation from Huawei, I think it was. In the
Okay.
slides. They said it. I think they like just bumped it up by like 10x or something. I can't remember.
Okay.
10x from what?
Yeah, so I was just
At
wondering
100,
because like
at 100, and I can't remember. I just remember they increased it. That's the.
Okay, let's go back to
I'll
this.
I'll
I think I
I'll,
missed it because it was
I'll
one of like the
find
6 a.m. ones.
it surprises me a little bit though, right? Like if they changed it from like 100 to 1,000. I mean, 1,000. I mean, think about that, right? Like that's a huge cap.
Yeah.
I mean, it's like crazy. That shouldn't. Once you get past like 100, even like 200 to 300, okay, maybe, but like that's.
Yeah, that was also a little bit surprising. Yeah, I mean, the question I asked actually was what the queue depth was for their clients. Because basically, if they have a small number of clients, they have to have a really deep queue before you would ever come close to that limit.
Yeah.
How realistic that is necessarily in like a real world scenario, but
Well, and how much IO depth can the device under the OSD even absorb, right? I mean, like
yeah,
you're throwing like 300 IOs, concurrent IOs at that device. You're
I mean
probably
that
saturating
the queue depth is limited at the blue store level, like it's pretty shallow there. So these it's probably just like
it.
making sure that
Yeah,
there's no slack, I guess, in the client. So like first queue.
yeah, exactly right. Like everything would have to be to even get to the point where you could saturate the device. You have to have that queue open wide, and like you said, you're probably just making sure that there's stuff in line to get through. But that's why I'm really skeptical that like bumping up to 1,000 would have like meaningful.
Yeah. Well, it might be worth just like trying to double it, say, and see what happens, just to see if it really.
Oh, well, yeah. I mean, Sage, you probably didn't see in the chat window. I've got a bunch of stuff.
Oh, I see. Oh, I see. Okay. Oh, so basically, once you hit 32, basically.
Well, I mean, there's a little advantage to going higher in some tests.
Sequential reads and some, yeah, sequential reads. Yeah.
It's kind of what you'd expect, right? Like for sequential, it's not that beneficial because you can just like mangle stuff together.
100 seems reasonable, though, I guess, these tests.
We were talking about like 256 as maybe being like a,
Yeah. Sure.
Yeah.
Okay. Well, the other part of that talk, there's a whole list of stuff, but the good news is that most of the stuff that they mentioned has already been fixed. There's some like page size stuff with 64K pages. It sounds like basically they've addressed the big problems and basically bumping up the page size on ARM like a 10% improvement or something, which is pretty nice. Even the right amp thing, I think the recent RocksDB DirectIO write read caching behavior thing does the right thing. But there's one other thing that we haven't looked at, and that's CPU partitioning. And this was something that I just like I don't even think I realized that it was a thing, or at least hadn't ever thought about in much detail. Where they basically set it up so that the threads that are processing like the op queue versus the like blue store dispatch KV thread, whatever, are on different cores, but on the same socket, and they pinned them there, and so that the like division of labor they would be work, whatever. They managed to get a reasonable bump from that.
What were they doing before that? Just letting them float?
Yeah, I mean by default, like the kernel just does whatever it
Yeah,
tells.
and I mean, you'd hope that the kernel wouldn't move stuff around constantly, but I mean, could have been.
Yeah, but it might be running them on the same cores, I guess. So it do one queue and then it do the other queue or whatever, and they basically force them onto separate cores. Which made me wonder if that's something that we could teach the OSD how to do automatically. I don't know how. I mean, so they also talked about NUMA pinning. They had a machine. Their machine had like the network and the PCI devices or the NVMEs were directly attached to different sockets, and so all the automatic NUMA stuff just worked, which was like great news because I don't know if I've ever actually managed to test that on a system that had like a balanced NUMA architecture. So that's good news. But it made me wonder if we could do the same thing for this other thing too. If we see that the socket, the NUMA node that they're on has multiple cores, we divvied up the OSD across those cores somehow.
I mean, yeah, you'd hope that in like write-heavy scenarios where the KV sync thread is basically just like pegging the CPU, like pegging one core, that nothing else would get scheduled on the same core because it's just like consuming the entire thing. But that means that we trust that the Linux scheduler is actually like sane and I don't know if that's a reasonable assumption, I guess.
And maybe the thing to do is like replicate the experiment and then try to understand what's going on. Like what's the behavior when you pin it? What's the behavior when you don't pin it? Like what threads are getting scheduled where? Maybe there's some kernel tunables that control the like the heuristics in the kernel's scheduler that might.
Yeah, I could see. I'm curious, like in their tests, do you know, did they have one were they doing, was this like small random writes? Was that what they were looking at where it showed
I
improvement?
can't remember. I don't think they posted a link to the slides. But
Is it the one our Stefan Arm talk? There's
this is the
one
very
link
first
I
one.
found in the. Is it this one?
Yeah, this is the one. Wait, no, it's not. No, it's not that one. It was
Okay.
I'm pretty sure it was Huawei who did the talk. In a YouTube video.
I mean, on ARM, I think that ARM, I might be totally making this up, but I thought ARM tended, compared to x86, to have higher context switching overhead. It may be that they're seeing have a very specific effect.
I think this is the one. I think the second one I pasted here. They are talking about messenger throttle and NUMA pinning and etc.
Yes. Yep, this is the one.
Okay.
So it was slide 11. And they showed this is so they got between like 5 and 20% improvement with different workloads.
I see.
But it looks like they didn't show a lot of detail about.
So, do you know what they were comparing it with? Was it
I think just without pinning was my understanding.
and not also not restricting threads to any particular NUMA node or anything? It was just like random
I
over
think
the
it
whole
was
machine.
the default NUMA aware thing, so NUMA auto or whatever it's called,
Okay, okay,
and that just already did its thing, right? So the
yeah,
OSDs themselves were confined to a NUMA node. This additionally divvied up the different threads.
sure.
Yeah, the messenger worker, TPOSD, and vStore threads. Yeah, so basically all the messenger and OSD stuff was on one CPU, and then the BlueStore threads, KV store sync thread, and the finisher stuff was on the second CPU.
Yeah, I mean, you could imagine that if the scheduler was stupid and like migrating stuff around, then that would not be great, especially if it was moving it to a different like cache domain for some reason.
Yeah.
It'd be nice if they had any data on what was going on in that case in those tests, like whether or not they were seeing a lot of processes moving and where they're moving between. We could do it in house.
Yeah, I mean, I guess a more general question even is just like, does that behavior carry over to Intel ARM systems?
Yeah,
Like
yeah,
maybe it's different.
and it might, but it might not have the same impact too, right? Like it might be that you can absorb it easier. Maybe it's 2% instead of 10%.
Yeah. Yep. Well, anyway, something to throw on the
How would
pile of stuff to look at.
how would this work in a container world? That gets all really messy.
I mean, right now, both the Rook and the Ceph containers aren't doing anything as far as trying to confine containers to anything. So it's no different than a non-containerized case. So the OSD is sort of, in the NUMA case, it's doing it. It's setting its own whatever to confine itself to a node based on the devices it's using.
We're going to need to let both Ceph and Rook handle this kind of situation for Crimson, though, for splitting up cores. So the solution for that might be maybe applicable to existing OSD potentially if this kind of partitioning proves promising.
Sage, does the OSD inside a containerized environment even have the ability to tell what NUMA node it's running on or any of this other stuff?
Mm-hmm. Yeah, I mean, in Ceph the container, I think even in Rook, the container has all these system privileges, so it can look in sysfs.
Okay.
Like all the hardware it's talking to, whatever. So yeah, it should be able to deal with. It should behave the same.
And then how do the... Oh, go ahead.
I was going to say probably at the point where we start trying to have the container orchestrator direct it to a particular CPUs or set limits or whatever, then we'll have to make sure that these two things play nice together. But so far, container orchestrators haven't done any of that.
Yeah, and Kubernetes might be a little bit more complicated because they have a kind of a different concept of CPU sets. That's like the Kubernetes scheduler controls.
Mm-hmm.
So it's unclear if I guess we might need to play nicely with that versus having the OSD do it itself.
Yeah, Josh, that's what confuses me is I thought that in Kubernetes at least, I thought that it controlled a fair amount of this. I don't know how the OSD does it.
I think it's a can control, not does control. So
Yeah, by
you
default
have
it
to
doesn't.
tell it
It's
to
not even turned on.
yeah.
So.
Oh, okay.
So the point at rook like sets some scheduling properties that tell it to pick a CPU or use this many CPUs or whatever. Then Kubernetes will go and allocate something. And the approach we took with the memory restrictions is basically that Ceph ADM just tries to mimic the same container inputs that Kubernetes does, and so from the daemon perspective, it looks the same. We'd probably do the same. But when we get to that point, we'll just need to understand how Kubernetes is doing it and how that's communicated into the container, and then try to mimic that.
I suppose one downside of this, right, is that if you're pinning the TPOSD TP threads and then the also the kbsync thread to specific cores, it does kind of take away the ability to kind of dynamically adjust things, right? Like if you have RCB compaction threads come in that all of a sudden are using a bunch of CPU or other stuff coming in using CPU, the scheduler can't be like magically rearranging it.
Or like more OSDs are deployed on the same node. So suddenly
things
you're over or undersubscribed and like
things get
I mean,
complicated.
ideally it would be nice if the scheduler just did it all on its own.
Yeah. I wonder a little bit if we would be better off trying to understand if the scheduler is behaving badly, and if it is, there's a way to make it better.
I guess either way, the first step is to replicate it and see
Yeah.
how big the difference really is.
There's been some desire to do graviton testing on AWS. I wonder if it'd be worthwhile to try doing this there, just to have another ARM set up.
Yeah, I mean we have a bunch of ARM systems. I think there's some that aren't being used for build yet.
Yeah, I just meant to. Go ahead.
I would probably try to replicate this on Intel first, just to see. This is probably going to affect more people. Anyway.
Yeah.
All right. Well, that's all I had.
Cool. That's kind of all we have in general right now, unless anyone else has anything that they'd like to bring up this week. All right. Well then, have a great week, everybody.
All right. Have a good one.
Thanks. See you.
Thanks.
Bye.
Yeah.
Thank you. See you.